Here you are. You're back for more videos. I'm trying to make you some videos. We're both here for a reason. Let's get to work. We've already been dealing with adding and subtracting fractions. Sometimes the denominator is the same. Excuse me. Sometimes the denominator is not the same. It's an unlike denominator. Whew! That's tougher. Let's warm up our brain a little bit by looking at all these equivalent fractions. Did you know that 1/7 is the same as 2/14? They're the same. They're also the same as 4/28 and 5/35 and 6/42. They're all the same. As long as you can follow a pattern on the top and bottom of a fraction, the fraction will technically be equal still. Yeah, like 1/7. We times the top by 2, and then we multiplied the bottom by 2, and we got 2/14. For 4/28, we multiplied the top by 4 and the bottom by 4. What's 1 times 4? 4. What's 7 times 4? 28. And they stay equal. Why do they stay equal? Because you did the same thing to the bottom that you did to the top, the numerator and denominator. To fill in this blank, all we have to do is follow a pattern. Maybe you see it just by looking. 1, 2, blank, 4, 5, 6. A 3 goes in that blank. And that makes sense. Because in order for that 7 to become a 21, you have to do 7 times 3. And whatever you do to the bottom, the denominator of a fraction, you must do to the top. 1 times 3. That's a little warm-up. Let's work with some actual problems that we have to beat up. In Cheyenne's apartment complex, 4/5, thank you, of the apartments are 1-bedroom apartments and 1/10, thank you, are 2-bedroom apartments. What fraction of the apartments are either 1 or 2 bedroom? So they want to know what fraction is either one. This is an addition problem. 4/5 plus 1/10. Here's the problem. Maybe you see it first. The denominator is not the same, and we need the denominator to be the same. We need it. Okay, we need it. Lucky for us, that 5 can become a 10. How can that 5 become a 10? You multiply it by 2. 5 times 2 equals 10. Whatever we do to the bottom, the denominator, we must do to the top. So let's do 4 times 2 up there, because we did times 2 down there. 4 times 2 is 8. Now we're ready. The denominators are the same. 8/10 plus 1/10 equals 8 plus 1? Simple. 9/10. Slam, blam, thank you ma'am. Moving on. Yiji, I think, and Clara own neighboring cornfields. Okay, I guess they're both farmers. Yiji harvested 5/6 of an acre on Monday, and Clara harvested 1/2 of an acre. How many acres did Yiji harvest and Clara? How many more? How many more? Ooh, subtraction. So Yiji did 5/6, and Clara, subtraction, how many more? 1/2. We have the same problem we had before. Denominators are not the same. We must get them to be the same. This 2 can become a 6. It really can. 2 times what equals 6? Think about it. 2 times 3 equals 6. Yes. And since we did times 3 on the bottom, we got to do times 3 on the top as well. You just have to. Got to keep it balanced. Now you have a new fraction. 3/6. The denominators are the same now. So 5/6 minus 3/6 will get you 5 minus 3, get you 2/6. That can become a more beautiful answer. I know you finish a subtraction and you want to stop because you're like, oh, I'm done, thank you. But if you can see it with your little eyeballs, that 2 and 6 can both be divided evenly by the same thing. They can both be divided by 2. 2 divided by 2 gives you 1. 6 divided by 2 gives you 3. 2/6 reduces, simplifies into 1/3. 2/6 is correct, but 1/3 is a superior, a better answer. Now we've got some mixed up numbers. Oh my goodness, look how hard this is. We have denominators that aren't the same. Those aren't the same. We have whole numbers. Oh my goodness, don't freak out. Do the whole number first. 10 plus 1 is 11. Put that to the side for later. Now we'll do the fraction. But the fraction isn't the same. We can make them the same. 5 can become 10 if you multiply it by 2. If we multiply the bottom by 2, we got to multiply the top by 2. 5 times 2 is 10. 3 times 2 is 6. Now we can do this. 1/10 plus 6/10. 1 plus 6, no problem. 1 plus 6 is 7. 7/10. Don't forget that we added the whole numbers first. That's how we got that 11. The whole answer altogether is 11 and 7/10. Sorry, I circled like a maniac there. That's supposed to be a circle, sorry. 11 and 7/10. Let's try it again, step by step. Do the whole numbers first. 5 and 1. 5 plus 1? 6. No problemo. Get the bottom of the fractions to be the same. 2 can become an 8. It can. If you multiply 2 times 4. If you do times 4 on the bottom, you got to do times 4 on the top. 2 times 4 is 8. 1 times 4 is 4. Now we've got 4/8 and 1/8. Adding that together, 2 seconds. 4 plus 1 is 5. 5/8. 6 and 5/8 all together is our final answer. That wasn't so bad, was it? Same thing, some subtraction. Keep practicing together. We'll get this, don't worry. Whole numbers first. 9 minus 5. Okay, 9 minus 5. It's no problem. I can do subtraction. 9 minus 5 is 4. We would subtract these fractions second, but the bottoms, the denominators, are not the same. We can make them the same. 3 times 4 equals 12, doesn't it? Times tables, yeah? 1 times 4. Because whatever you do on the bottom, you have to do on the top. This becomes 12. 1 times 4 is 4. Oops, I did some accidental clicking there, sorry. Now we can subtract, no problem. 11 minus 4? 11 minus 4? Easy. 11 minus 4 is 7. 7 what? 7/12. One more together. Do the whole number first. 12 minus 10. What is 12 minus 10? Come on. Simple subtraction. 2. Now we will subtract the fraction part, but the fraction part is not the same on the bottom, and we need it to be the same on the bottom. Hey, don't get me wrong. I wish it was already the same on the bottom. That'd be easy, but we have to make it the same on the bottom. How can 4 be 8? Times 2. That'll get it to be 8. Whatever you do on the bottom, please do on the top as well. 4 times 2 will give you the 8 that we need, and then 1 times 2 is 2. 2/8, 1/8. 2 minus 1. Ha! 2 minus 1? It's 1. 1/8. Final answer. Here's a preview for your pop guide. I'm not going to show it very long. A couple word problems. Some more of these, you know, adding this all together. The denominators aren't the same. You're going to have to make them the same. And then a little bit of writing. What should you do first when adding or subtracting mixed numbers? Mixed numbers are the ones that have the whole number right there, not just a fraction by itself. That concludes the video. I hope you guys will replay it. If you need some extra help, don't forget to check IXL.com for further practice. Thanks, guys.